The IP command allows you to manipulate network interfaces, network devices, so it's a very powerful command. For example, you might use the IPA command, which is short for IP address show. For information about the IP command, there's two places that you're going to want to go. You're either going to want to go to IP-help or the manual page, man IP. And so for the short version of the help feature for the IP command, IP-help. For more in-depth information, use the manual page and man IP. So let's show both of those now within a Linux system. And here I'm working in a Debian client system, and I already have a terminal opened. And if we type IP-help, we'll get the help file for the IP command. And so you have the IP command itself, and then you want to know the object that you're working with. So for example, IP address, which can be shortened to IPA, or IP link, or IP route. And we'll show all three of these in this deep dive video. You can then place options in between the IP command and the object. So if you want to work, say, with IP version 4 by itself, you could do that with the -4 option, or -6 for IP version 6. Or if you want to work with JSON, -J. But those options would go in between the IP command and the object in question. So if you wanted to see just version 4 IP addresses, you might do something like IP-4A or address. And that will show you that information. Okay, so the help file, it's very good to help remind you how a command works, gives you the basic options. But if you want to go into more depth, you want to see the manual page. So you can do a man IP to bring that up. That'll open up the manual page. It'll give you a synopsis about everything that the IP command does, and that's essentially the same as the help file. But then if we scroll down here, you'll see all the options, what they do. You might get examples when you're in a manual page. You might get additional command syntax. So there's a lot of information here for the objects and the options that you can work with here. Now, I mentioned I'm scrolling down here because I'm actually working in a Linux system that has a GUI. It's got the GNOME desktop. If you don't, you could use the arrow keys, and you could use page up, page down, or you could use the less option when you're working with this. So you might do a man IP and pipe it to less to be able to show everything by the page. So you might need to do that as well. When you're done, you can press Q to quit out of the manual page. So that's the first stop for me all the time. I'm always going to be looking for information about a command because you're not going to remember every single option, or in this case, every object that you might be working with this particular command. So the help file and the manual page are very, very important. That's always my first stop, is the documentation. The first object that I want to work with is the link object. So this will be the IP link command. And the default command for IP link is IP link show. So if we were to type IP link show, that's going to give us information about our network interface card, our network interface device in Linux. You can abbreviate this. The default for IP link is IP link show. That's the default option. So you could just type IP link and you'll get the same information. Furthermore, you could simply type IPL and just abbreviate it down to that. So that's the easiest way to do it. So that's how I'm going to do it here. The IPL command. Let's make the font size a little smaller here. Clear the screen and run that command again. Okay, so there's our IPL command. So we see three connections here. We see LO, we see ENP1S0, and we see Docker 0. The one that I'm really concerned with in this video is ENP1S0. That's my actual network connection. That's what I want to work with. But let's just talk about the others real quick. LO is the local loopback. It's the local device. Every system gets one. Docker 0 is there because I actually have Docker installed on this system, so it gets its own network connection, but it's more of a logical network connection. ENP1S0 is the one that I want to work with. That's the actual network connection for our network interface card here. And that's normally what you'll look for. You'll kind of avoid the local loopback and then look for that second connection. That's the main one that you're going to be working with. So you're going to see a couple things here. All of the information that you see here deals with layer 2 of the OSI model. And layer 2 of the OSI model is the data link layer. So we're talking about the OSI model here, where we're dealing with these layers. You can learn more about the OSI model in other videos that I offer, and also I'll be posting a link to that as well. But this is layer 2, the data link, the actual link between your network interface card and your wired network. And that's what I'm working with here, is all wired connections for this particular deep dive lab. So what do we see? Well, the most important piece of information that I'm looking at here is the link/ether. And what that means is the actual link to the Ethernet network. Most wired networks out there are Ethernet. That is the network architecture. And then following that is a MAC address. A MAC address is the media access control address. It's an address that's burned into the actual network interface card. It's burned into a chip on that card. So it's also referred to as a physical address. That's the MAC address. And it's shown in hexadecimal, and it's usually 6 octets. These MAC addresses are unique. Every single network interface card gets a unique MAC address. And this information resides on layer 2 of the OSI model. We use the OSI model to reference what's happening. We use it to kind of document what's happening and troubleshoot what's happening in networking. So that is the MAC address, exists on layer 2. And you'll see other information as well about our connection that deals with Ethernet. For example, MTU is 1500. That's the maximum transmission unit, and it's set to 1500 frames. Frames of data are what we deal with on layer 2. You also see a very important piece of information here, the state of the network connection. It is up right now. It is functional. It is working. If you look over here at the Docker connection, you'll see that the state is down. We don't have any Docker containers doing anything right now. That Docker network connection is not being used. But ENP1S0 indeed is being used. The state is up. Now, one important note to make here is that the system that I'm working with here is a virtual machine. It's a Debian client running virtually within my virtualization system. So that means that the MAC address that you're seeing here is a virtual MAC address. It's not an actual physical device. So let's show another system that's an actual physical system and show the MAC address on that. Here we have a system that I've SSH'd into. I'm calling it telemetry. And if we run an IPL command on that system, you'll see a lot of network connections. Okay, this is actually a super micro server with multiple network interfaces. First, the motherboard has 2 network interface connections. Linux is calling them EN01 and EN02, and this is very common. So these are 2 RJ45 network connections that go out to the switch, and they're built into the motherboard. Now, if you take a look, EN01 has the MAC address here, starts with AC, and it ends in 63:66. Then EN02 also starts with AC, and it ends in 63:67. So as you can see, every MAC address is unique. The first 3 octets tell you who the manufacturer is, really. This is the organizational identifier. And so that's the first 3 octets, and then the last 3 octets identify the individual device that they have built. You will also see more network connections starting with ENP4S0F0. That's just the name that Linux has given this, but this is the first of a 4-port network interface card that I put into this Supermicro server. And so it's a single card, but it has 4 ports, and each port is essentially considered its own network interface. So each port gets its own MAC address. ENP4S0F0 starts with 26 and 1A, and it ends in D6, 6A. If you look further, we have ENP4S0F1, then we have ENP5S0F0, which has a separate MAC address, and ENP5S0F1 with a separate MAC address as well. They're not always going to be labeled in order of the MAC addresses. Sometimes you're going to see a little bit of a difference there. So that will depend. Also, if you have bonding or other types of things running, you may see it listed as the same MAC address, which is what we have happening on this system. Then we also have a wireless card here, WLP6S0, with its own MAC address. All right, so this is all stuff that resides on layer 2, the data link layer. And that's an example of an actual system with a 2-port network card built into the motherboard, and then a 4-port network card that I installed, and then a separate wireless card as well. Now let's work with the address object for the IP command. And this is what I use the most often. For example, you might type the IP address show command. And the IP address show command is great. That'll display all the information you need to know about TCP/IP for your network connection, but you can abbreviate that like you would with other objects with the IP command. So for example, you could just do IP address, or you could abbreviate that down all the way to the IPA command. Let's take a look at what this does here. When we type IPA, you'll see a whole ton of information in here about TCP/IP. To start, we see the 3 connections once again. The one I want to focus in on is ENP1S0. And so you see all of the information from the IPL command that we showed before. And that's our layer 2 information. But now we also see the layer 3 network layer information, the TCP/IP information. So for example, we see here it says INET. That's short for internet address or the IP address. And in this case, the IP address of this system is 10.0.2.52 with a /24. We also see the IPv6 address. And then you see additional information for each address, the scope, whether it's global. You'll see whether it's dynamic or not. This is not. It's actually a static IP address. And what network interface this IP address is actually assigned to. Well, it's underneath here, so we know that already. But that could become important information for you when you're troubleshooting later on. Regardless, all this information here is layer 3. And layer 3 sits right above layer 2. It is known as the network layer. This is where IP addresses exist. This is where IP packets are transferred. This is where networking is done. So essentially, it's all the IP information that you want to deal with. The IP protocol exists on layer 3. So you might hear this referred to as the network layer, in some cases the internet layer, or just layer 3. And you might say, well, Dave, what about layer 1? And layer 1 will be underneath here, and that, of course, is the physical layer. And we're talking about physical cabling, actual physical ports, and so on and so on. I'm not really too concerned with that in this particular course. What I am concerned with is layer 3, the network layer, because that's where all of the IP information is stored and where it occurs and where it's transferred. That's how we define it within the OSI model. So IP address show is an integral part of this when working with this system. Now keep in mind, we showed a couple things here. We showed the MAC address for a network interface card, and we said, okay, that is unique. That is burned into the network interface device, and it doesn't change normally, and it facilitates the communication of frames of data within an Ethernet network over that network connection. On the other hand, the IP address, that's our layer 3 address. This is assigned by the operating system, so it's separate. And I get the question a lot, are the MAC address and the IP address the same thing? They are not. The MAC address is burned into the network interface device. It is considered a physical address. It is unique. The IP address is something that could be applied manually by a person. It could be applied automatically by the operating system or obtained automatically from a DHCP server. If we were to wipe out this operating system, if we were to wipe out Linux off of the system, the IP address would be gone, but the MAC address would continue to live on within the network interface device. Right? So I consider this to be a physical address and this to be a logical address. MAC address is physical, layer 2 data link. IP address is logical, layer 3 network layer. Let's show the OSI model in a little bit more depth here. You can see I have all 7 layers listed for you, and their names. We said layer 2 is the data link, layer 3 is the network layer, and here's all of the other layers. But I also wanted to show how they apply to Linux. If you look here on the left, you'll see that we have user space, the kernel, and hardware. So hardware is always hardware. You have a network interface device, it's an actual card, that's considered layer 1, it's the physical layer. The kernel of Linux is the core of Linux. It's the core of what everything is of Linux. And essentially with the OSI model, that comprises layer 2 through 4. That's the data link, network, and transport layers. Then you have user space in Linux, which is the session layer, presentation layer, application layer, and when you actually type commands in the terminal. So I use the IPA command a lot, but you may look at this information and you say, okay, that's too much information. I want to sort through this or filter it. And so I do that a lot as well in the field. So let's show how to work with some customization of IPA by working with different options. First, I'll clear the screen here and we'll do this. We'll do an IP-BRA. So this would be like an address show, but what we're doing is we're adding in that option -BR. Now remember, when we showed the help file, we said, okay, there's the IP command, then there's the object you want to work with, and then there's options that you can add in between. And you would put those in between the command IP and the object in question. So here I'm putting that option in between there, and I'm using -BR. And again, we can abbreviate that down right to A for address show. So this is an IP-BRA. And when we press enter, we get brief information. That's what -BR stands for. So we get nice brief information in tabular format. It tells us the state of the interface and the IP addresses. So we have ENP1S0, that's the network interface. It is up right now, and we see the IP address for that, and also the IPv6 address for that particular device. So I use this a ton. It's a much simpler way of getting the most important information that I'm usually looking for when I'm working with servers or other Linux systems. It's also helpful if you have a lot of network connections. So for example, If we look here and we go back to this system, which I called telemetry, this is actually Ubuntu running on a Supermicro server. When we did an IPL, we got a lot of information. Imagine IPA, it's going to be pages of information. So we can easily break that down by doing something like an IP-BR and add in the -C option, which is for color, and then A. So yes, you can have multiple options here. If we do that, we see all of the network interfaces on this particular system, the state of those network interfaces, and then the IP addresses for each of those network interfaces. So when you're working with a server like this, this command really is something that I can't live without. I need to have it. And the -C is nice because it color codes everything. Green is good for up, red is bad for down, although I don't really care too much about the virtual bridge for KVM right now. We know that our wireless connection is up and it's connecting to a Soho router at this network. We know that our main connection is up and this is its IP. And in fact, I'm SSH'd into this system right now on that IP address. Here's another system, and this one's called Parallax. This is actually a Proxmox server, and it's running on a Dell R630. If we run an IP-BR-CA on that, you'll see all the connections for that as well. And this actually bridges each of the connections automatically for us. So this particular server has a network card with 4 connections, EN01 through EN04, but it bridges those automatically as VMBR1 through VMBR4, and that's where the actual IP addresses get applied. That's the first interface, 10.42.0.11, and that's actually what I'm SSH'd into right now. And the last one, 10.42.0.14. So we have that range there, 4 ports altogether. And so again, this is running Proxmox, which actually runs on top of Debian. So great command to use to see a lot of information. Could I see this in the GUI of Proxmox? Yes. If I'm running Ubuntu with a desktop, could I see that in the GUI there as well? Yes. But I prefer to just SSH into systems and find out as much as I can right within my own terminal from my main workstation. But that's a great command that we can use here. Let's go back to the telemetry system, and I'm going to go full screen on this, clear this, make it slightly bigger here. Now let's show some more examples of ways that I might modify the IP command. I have to be honest with you, that IP-BR-CA is pretty much the primary way that I use that command when I'm analyzing a system. But there's other things that we might do here. So for example, I might do the IPA command, but I might decide to filter that command. We could pipe that command and add additional information here. For example, this, grep space inet, which means it'll just filter for any lines in the command that had that inet option. We'll leave that open and show this system real quick again, my virtual machine that we're working in. We said inet means internet address or IP address, and it's followed by the IP address and various other information about that particular logical connection. So we can filter out just those lines from the IPA commands. So for example, we could use grep and inet and then pipe it again and use the sort command to sort everything numerically. Press enter and it shows all the inet line items that we would get from the IPA command, but just those inet line items, and it's sorting them numerically, as you can see here. We have the 10 network, then the 127 network, that's just the local loopback. Then we have the 192 networks, and then the IPv6 networks, which I'm not really getting into in this video. Now, something I didn't mention was that 127.0.0.1 yet. Haven't mentioned that yet. And if we look back here at our virtual machine, we see the local loopback connection, and we see 127.0.0.1. As you can guess, every system that runs TCP/IP gets this internal IP address. It's the local loopback, or just loopback address, 127.0.0.1. And it's used for testing and so that the system can talk to itself and do self-diagnostics. So that is assigned to every single system that runs TCP/IP. It's the local loopback. It cannot communicate with anything else on the network. That's what we use our logical addresses like this for. Getting back to our telemetry system here, our Ubuntu system, we can do additional things here with this sorting. You can sort however you want. You can filter however you want. So if you wanted to filter for other information, just change that out. If you wanted to sort in another way, you could do that as well. If you want to add additional commands, you could do that too. Another option is to use the one-line option. So we could do an IP, and this is an option, so we're going to put this in between IP and A, but it'll be IP double dash one line, and then the A. And another way of modifying this, we could pipe this and put in another command. We could use something like column-T, which will make this nice and columnized. Press enter for that, and we'll go a little smaller here so you can see it better. But we will see the one-line information, which is a built-in option as well. And so, for example, we can see EN01. We see the IP address. We see the broadcast address, and so on and so on. So you might like that command as well. That's the one-line option. Or you might want to go in the other direction and get more detailed information in other formats. For example, you could show the same information of IPA, but in JSON format. So we could do something like an IP-J for JSON, and the A. And when we press enter, you get a ton of information here for all the network interface devices. And then you could export that if you wanted to a file to be consumed by something else later. So we could do something like this. Just say this could be IPA info.txt or .json and export that out so it can be consumed by another program later on. That's not very human readable, and there's so many devices on this particular computer, so it might be easier to show this on our virtual machine. So if we do that here, IP-JA, you'll see less information because there's less connections on here. If you wanted to make it more human readable, we could add another option, and that's -P to kind of prettify it, and press enter. And then you'll see everything in more human readable JSON format. All the information about this card is here. This is all the loopback info. And if we scroll down here to the next array, we have EMP1S0. Everything is here as individual items. This equals this. MTU equals 1500, right? The state, which is actually known as upper state, is up, and so on and so on. So this is the JSON look. You might also decide to do this by using JQ. You could pipe this information to JQ to make it look real nice and colorful and so on. So a little bit more human readable, but you'd have to install JQ to do that. Jump back to our Ubuntu system here, and just for fun, we'll add a couple other things here. You might do something like this, something very in-depth by using the sed option. It's really the sed command. Sed can be really good if you need to filter out specific types of information, if you're working with a lot of files or databases and so on. As you can see, the syntax is very complex for this. But if I run this, what am I getting? I'm just getting the IP addresses for this system. So all that syntax is allowing me to show just IP addresses. So SED is great, and it allows you to filter out information in an awesome way and in a very in-depth way. And so if you need to get information from servers or workstations and multiple systems, SED can be very powerful. But you always want to look for additional methods or perhaps easier ways of getting your work done. This might work very well in a script, but if you want something a little bit faster, you might go a different way. You might go with, say, the grep option and filter out things, or you might choose to use awk. And so another way to do this would be to use the awk option, and I might do something like -O -4. So we're only getting IP version 4 here, and it's a one-liner. That's what the -O is. That's the same as /1 line. And I might specify something like this. I might say A, and then pipe this to awk instead of SED, and then do something like this in single quotes and in curly braces. I might say print $4, meaning I want the fourth item of information. Close out the curly braces and the single quote. And there we go. We're just getting the IP information from the one line option. So if we show that one line again, let me show that from another system just to make it simpler. That was IP-1 line, ADDR. I did it like this. Or you could just do O and A, and you'll get those one-line informations for each of your cards. And what you're looking for is the fourth piece of information. We've got 1, 2, 3, 4. That's the fourth item of information in that one line. So we can use awk to discover that for each of the items. 1, 2, 3, and 4. So that'll just grab the IP address every time. And that's what we're showing here. On this other system, just the IP addresses. So that might be an easier way, especially as compared to this syntax that I was using here. And in addition, it might work better just as a quick command, or it might work better for you in scripts. So always try different commands here. And you might notice there is a difference. This showed the IP address, but it's not showing the CIDR notation. Down here, it's showing the IP address and the CIDR notation, but we could cut that out. If you ever want to cut information, you can do that as well with the cut command. So we'll do another pipe, use the cut command, and I'll say -D/ and we'll say -F1. Press enter, and now we just get the IP information. A little bit more complex, but still a lot less complex than using this. And we're essentially getting the same information. And I'm only showing IP version 4 here because I used this. If I was to take that out, I would also show the IP version 6 addresses. In this case, we just have link local IPv6 addresses. And a note here, you may have worked with older commands in the past, like ifconfig, or maybe the route commands. And these are considered deprecated commands, but you can still get access to them if you want to. Now, for example, I'm going to go over to this other system here. This is my Proxmox server. And if we were to run a command like ifconfig, you're going to see commands not found. Now, a couple things about that. It may actually exist on your system. It might be located in sbin. Or if you don't have it at all, you might be able to install it. If it is located on your system somewhere else, you might need the sudo command to actually run it. And you might need to actually type the path to the command. If it's not installed at all, you can install that by getting the net tools. And that's an apt install net-tools. And that gives you a variety of tools. That gives you the original ifconfig, which BSD still uses, by the way, and so does macOS, and route, and ARP and a couple other tools. Those are considered deprecated tools, but I actually use ARP once in a while. But you never know. Maybe you need the ifconfig command for some reason and it's not loaded on the system. This is the way that you would get it on Debian or Ubuntu at least. If you're on Fedora or Red Hat or what have you, DNF. But again, it could actually be listed there. You can check it, and that would be in /usr/sbin. And if we take a look in there, we could see if ifconfig actually exists. I should have just filtered it out, but you can take a look in here if you want to see if it actually is there. And we do have if down, if query, okay, but no actual ifconfig. So that's something you can check out. Proxmox has a couple older commands. Ubuntu and Debian will have less. But again, you can add those just by doing that apt install net-tools if you ever want to get access to those. So IPA, very powerful. Again, what I use the most often is IP with the -BR and -C options with the A to get the IP address and the name and the status of those network interface devices. You can apply many of these options to other IP objects as well. Just imagine the possibilities. So consider searching for and practicing with the IPA command. Okay, last object I want to show for the IP command in this deep dive is route. Route deals with IP routing, the connection to other IP networks. So let's show that now. The first command is IP route show. And so once again, that's the main and default command. Do we need to do it that way? No, we can just do an IP route, or we can abbreviate that to IPR. And when we do an IPR, we'll show the default gateway for this system and the routes that we have available on our system. And by the way, going backwards a little bit here, you might ask a question, hey, can I combine these two options together, -BR for brief and -C for color? And the answer is no, you can't do a -BRC. You'd have to actually state them separately as separate options. That's how you're going to want to do that with the IPA command or the IPR command or whatever object you're working with. So what do we see here in the IPR or IP route show command? Well, we see the default connection. That's our default gateway. And we see that it's connecting via 10.0.2.1. Well, my IP address is 10.0.2.52. A default gateway needs to be on the same IP network. The IP network I'm using is 10.0.2, and that is the case here. So our default gateway is 10.0.2, and quite often that gateway device or router will be the first IP of that octet. So it's 10.0.2.1. That's my gateway connection. That's the device that's allowing me access to other networks. And you see the device on this local system that's using that default gateway. It's ENP1S0. That's my main network interface on this Linux system. We see it's a static connection, and we see the metric. The metric qualifies the connection. The lower the number, the higher the priority for that network connection. We see two other line items. We see 10.0.2.0. That is a network that I'm allowed access to. And that's because I gave the IP address 10.0.2.52 to this system. The IP network that you're a part of is going to have 0 on the end. That's the entire IP network. So the entire IP network for this system is 10.0.2.0. My particular IP address is .52. The gateway IP address is .1. So you see how that works. So we have connectivity to any other systems on the 10.0.2.0 network. And it shows us also that we're using the ENP1S0 device to get out to that, and that IP address for that device is .52. We have a connection to another network. That's the Docker network. which by default, when you're working with Docker, uses 172.17. That's the network number. You can create additional networks in Docker if you want to, and I do that sometimes, but by default, 172.17. And so the Docker device by default will get 172.17.0.1, and we have a routed connection to the entire 172.17.0.0 network using that Docker 0 connection on this IP. So any networks that you gain access to via TCP/IP will be listed with the IPR command, and probably more importantly, your default gateway is listed right at the top. We can modify this command as we have before. We could use color, and we could also set it to work within columns with a column -T. And I'm sorry, I put the -C in the wrong place. Got to have it between the IP command and the object. There we go. So now we have nice columns, and we have some color as well. IP addresses are in purple in this case, or magenta, if you will. The color may be different for you depending on your color scheme, but it shows the IPs, it shows the device, it shows the source in a nice column format instead of reading this. So this command may make it a little bit easier for you to read the information. You might also choose to just filter out specific information there. So you might do something like this and do a grep on the term default, just as an example, and it'll just give that default line item. Or you might do that for metric. You might say, okay, I want all the line items with metric in there to see all the metrics for my different network interface devices. And that actually becomes important. So if we do an IPR command here, we'll see all the connections, and then we'll see the metrics for each of those. So we've got EN01, which has a metric of 101. We've got EN02, which has a metric of 102. We've got the other connections, which have higher metric numbers. Remember, the lower the number, the higher the precedence. So it's kind of one of those inverse things. The lower the number, the higher the priority or the precedence for that network interface. So EN01 is going to be the first device that's going to be used on this system if network connections need to be made. Let me show my main system for a moment here, and we'll do an IPR on here. Okay, this is the main system that I'm working on, and you'll see that it has multiple connections as well. We've got ENS6F0, ENS6F1, so that's a dual network card. And I've actually set the metrics on these. I set ENS6F0 to 80, and I set ENS6F1 to 90 so that it won't get in the way. We've got BR0 set to 100, and then a wireless connection, which is set to 101. And I've done that on purpose so that specific connections will have higher priority. If we look further down here, we see this particular IP address on ENS6F0, that's getting the metric of 80. This IP address on ENS6F1 has a metric of 90. It's actually bridged to this with a metric of 100. The reason I'm doing that is because all my virtual machines are working in this bridge, but I don't want the virtual machines to get a higher priority to my network connections than my main system. So my main system has a lower number, so it has a higher priority, and the virtual machines will be secondary, which is really important when I'm doing any kind of recording or doing live streams and so on, because I want my main connection with my video and my audio and all the applications that I'm running to get the highest priority. And the virtual machines, they want to have secondary priority. Now, they are separate network interfaces physically, but I want the Linux system to give the most thought process, the most processing power, the most in the way of resources to that main connection. So I give that the lowest metric number. Okay, so let's show the route table again on our virtual machine here, and let's go through a scenario. And the scenario is this. A server is malfunctioning, and a manager calls and is very upset and says, server's not working. Nobody can connect to it. And so we need to fix the problem. This is an actual thing that's happened to me more than once in the past when troubleshooting servers. So we can simulate this problem. Now, the first thing I want to do is I want to take a look and make sure that my system can connect out to the internet. So we'll do that with a ping example.com, and we can see that we are getting replies here. So that is good. Now, what I'm going to do is I'm going to simulate the server having no default gateway. If you don't have a default gateway, you're not going to be able to connect to anything. Now, if you're going to run this simulation, I recommend that you do it in a virtual machine. Don't do this on your main system. Don't do it on your server, because you're going to lose your network connection. So if you're ever going to do any types of testing in Linux, I highly recommend that you do it in a virtual machine the way I am here with this Debian virtual machine. So let's simulate the problem by getting rid of the default gateway. We're going to do that with an IPR command and say delete default. And when we press enter, well, it says operation not permitted. That's because I haven't typed in sudo yet. Now, my particular account that we're working with here is called Dave. Dave does have sudo privileges, and you can see that here when I type the ID command. So I am in the sudo users group. I do have administrative privileges. I can do anything on this system, but I have to type the sudo command before any command that requires administrative privileges. So we'll do that now. If you needed a password, it would ask you for it. I've already done sudo on this particular system behind the scenes, so I don't need to type the password, but you'd have to supply that the first time you run sudo. And so we see no news is good news. In this case, it's actually bad news because we removed the default gateway. But I always say no news is good news. That means that we didn't get an error with the command. The command went through successfully. The problem is that it actually has gotten rid of our default gateway, which is going to hurt us because now we can't access any other systems. So let's show an example of that. Let's do another ping, and we'll go to example.com once again. And what does it say? Network is unreachable. That's because I got rid of the default gateway. It's gone. So you might say, okay, this server can't connect out to anything. Manager's yelling at you. You want to get this thing fixed. This is why these commands can be really powerful for you. Using IPA and IPR can be a great way to analyze the system and see what the problem is. If we run that IPR command, you'll see that that default gateway that I was showing before, it's not listed. There's no default gateway here. We can't see it. It doesn't exist. So we need to fix that. Not too hard to do. You can use the IPR command, and we can do an add default, and we'll say via, and the IP address we want to use to connect out. And so that's going to be the gateway address itself, 10.0.2.1. Oh, and I forgot sudo. I always forget sudo when I'm not working as root, because quite often I do work as root on a lot of my servers. Not a best practice if you're dealing with customer services. So quite often I'll forget sudo. But there we go. Put the sudo in, ran the command, IPR, add the default gateway back in via this IP address. Now, if we do an IPR command again, we'll see that the default is there. And it's using this device. I didn't specify that. If we had multiple network interface cards, you'd want to specify that. So for example, I might do something like this and specify that network interface card, whatever the name of it is, by using the dev, short for device, after the IP address of the gateway, right? So that's one way to get around that. But in this case, we only have one real Linux network device. That's EMP1S0. So it added the default gateway to that automatically. Now, if we run our ping command again, I'll just up arrow to that, we'll see that the pings are working. Fantastic. So a really, really easy fix for a problem that was massive and causing a lot of consternation and arguments and managers yelling and so forth, but a simple fix. As long as you analyze the system first before you actually start doing things, you can find out the problem pretty easily. You can also add new routes if you need to. Currently, we can connect to the 10 network and we can connect to the 172 network here. But what if you needed to connect to other networks? We can do that. We can do an IPR add and specify the network you want to connect to. So let's say I had another network like let's say 10.42.0.0 because that's one of my test networks on my lab. I'll put that in with the /16 because that's the subnet mask for that particular network, and then specify the device that we want to connect to that network. Now, I don't have any more devices on this particular virtual machine, so we'll just say EMP1S0, press enter. Oh, and again, third time in a row, forgot sudo. Getting deep into this deep dive, and I keep forgetting to type sudo, so my apologies. But at that point, that should add that additional network onto our list. If we do an IPR, we will see we have connectivity to 10.42. That's only if it exists, and that's only if this physical device can actually connect to that network in a physical fashion. If it can, and if that network exists on, say, the switch that we're connecting to, then we'd have the ability to connect to other systems on that network as long as we add an IP address for this system. And you can add IP addresses as well with, say, IPA. You can add things with IP link, but I normally wouldn't do that with this. I would normally use NMCLI for this instead because we're running Network Manager here. That's quite often the way I would do it. If it's a different system, if it's like an Ubuntu server, I'd use NetPlan. If it's a Debian server, I would configure the interfaces configuration file. But a lot of systems out there are going to be Network Manager based, so we'd use the NMCLI command to do that. So you can add IP addresses with the IP command, but generally those will be temporary. They will not be persistent. So they're good for testing, but they won't be permanently added. So that's another example there. If you want to get rid of that route that you added, we could do that as well. We can just specify delete instead of add. And look, I didn't forget sudo this time. Good job, Dave. Now, if we do an IPR, we'll see that that network has been removed. It's not on the list here anymore. All right, good stuff. And just for fun, if you're bored, do an IP moo. Anyways, if you like this video, feel free to subscribe. And until next time, keep networking.